Women in Data Science Worldwide has been around since 2015. We started pretty small as just one conference on Stanford campus, and our aim then was to simply feature outstanding women doing outstanding work in data science. And then we grew. We grew into a global movement, connecting women and also men around the world.
WIDS has grown organically, responding to what the needs of the community are, what women data scientists need, and exploring new ways to interact. Stanford University is proud to have been the birthplace of WIDS and a decade of growth. With our unique strength in data science, computation, and AI, Stanford was the ideal incubator to support this force for advancing diversity in data science. WIDS has had a lasting impact on data science at Stanford, with a co-founder of WIDS as a founding member of Stanford Data Science. Including multiple perspectives is baked into the core identity of our programs.
It's critical, and we need women in these roles. Every individual brings their own perspective, and so we need to make sure the entire workforce is represented.
Because it really fosters that sort of community building you want when it comes to not just data science, but really any, I think, efforts to try and engage more girls and women.
So the fairness mission that we have is really try to enable that two people with equal talent should have an equal shot at opportunities.
I also just encourage people not to give up and keep arguing for what you believe in and what's important to you and what you think will make a difference.
WIDS is about the sense of urgency we should all feel to ensure that women earn that seat at the table based on their skills and talent across the world.
WIDS has inspired me to believe that more is always possible.
WIDS has inspired me to think big. WIDS has inspired me to learn more.
It brings together some of the leading scientists in the world.
The journey is just beginning. At WIDS, we're not just envisioning a more inclusive future in data science and AI, we're making it happen. From equipping students with critical skills to advancing career development, we're expanding access to education, mentorship, and empowering support for tangible impact. The next decade starts now, with action, with us. Join us in shaping the future. Volunteer, mentor, or donate today.
Good morning, everyone, and welcome. I hope you can hear my voice now. I'm so glad to see you here for our Women in Data Science workshop. I'm Dr. Aisha Hamdi, working as Assistant Prof at the College of Engineering and Computer Science at Jazan University. I've got my master's degree in Information System from the University of Michigan, Flint, United States, and got my PhD in Internet of Things from the University of Technology, Sydney, Australia. Today, we're going to explore something exciting and deeply relevant: how educators can step into the world of data science and use it to transform learning. Education has always been about understanding learners, their progress, their challenges, their potential. But in today's classrooms, we have something our predecessors never had, which is data. Every click in a learning system, every quiz score, every feedback form, all of it tells a story about how students learn. And that's where the magic happens, where teachers begin to think like data scientists. When we look beyond grades and see patterns, relationships, and insights, that helps us personalize learning and improve outcomes. That's what this workshop is about: bridging two worlds, the heart of a teacher and the mind of a data scientist. As part of Women in Data Science initiative, this session is also about empowerment, showing that you don't have to be a mathematician or a programmer to use data meaningfully. You just need curiosity, compassion, and a willingness to explore. By the end of our session, you will see that the path from teacher to data scientist isn't a leap, It's a natural step forward. So let's begin our journey, starting with how the role of teachers is evolving in the age of data and technology. As we know, in the past, teachers relied on observation and instinct and paper records. They were using chalkboard to explain the different materials to their student. But today, technology captures massive amount of information. Student attendance, engagement, quiz scores, feedback, and even eye tracking in e-learning. This evolution gives teachers new superpowers: the ability to interpret patterns and predict learning outcomes. We used to grade papers and rely on intuition, but now we can, for example, visualize learning data and identify which student need help before they even ask for it. So now, as a teachers, we are able to supervise our student and see which student need help before the end of the semester. When we think of data scientists, we often picture someone writing code or like building algorithms, but the truth is, teachers have been using the same thinking processes long before data science became a field. For example, the teachers start by observation. A teacher's job begins with observation, noticing who is engaged, who is struggling, who finishes early, and who needs more time. In data science, this same step is called data collection. Just as data scientists gather dataset to understand a problem, teachers gather learning evidence every day from the quizzes they give to their student, from the classwork, from the student participation, or the student attendance. This means teachers already think like data scientists. They collect information before making decisions. So, a good teacher always observe their student and watch their performance through the quizzes, through their participation during the class. Then comes reflection. After observing student, teachers reflect. Which lesson worked well? Which activity confused them? Why did many students miss the same question? In data science, this is analysis, looking for patterns, connections, and causes. Teachers naturally analyze trends in student behavior and performance, just without the statistic software. It's the same cognitive habit, simply applied in the classroom instead of a dataset. So after the teacher observes student, they use the collected data and analyze it to move to the next step, which is improvement. Based on reflection, teachers make adjustment. For example, change the lesson plan, add more activities for students, slow down through explanation, and also they can offer extra help for students who need help. In data science, this step is known as modeling, which is using insight to predict what will work better. When teachers adjust their teaching to improve outcomes, they are essentially doing what data models do, which is use past information to improve future results. This is why teachers are naturally suited to data science. They already practice continuous improvement. So the shift toward data-driven education isn't about replacing the teacher, no. It's about empowering the teacher with tools that enhance what they already do, which is observe the student, analyze the collected data, and then use this analyzation to improve the way they are teaching. Every good teacher already performs a form of data analysis, interpreting student behavior, exam result, feedback, to make evidence-based decisions. Now, let's look at few real examples of how teachers are already using data-driven methods in classrooms and universities around the world. For example, tracking attendance versus performance to identify at-risk student. One of the simplest and most powerful uses of data is comparing attendance with student performance. When teachers notice that students with low attendance often score lower on assessment, they can intervene early before the student falls too far behind. Something as basic as attendance grade chart can help identify at-risk learners and also trigger timely support. So when the teacher continue observe and watch the student performance, he can help the student before it's too late. Then, using learning analytics dashboard in LMS platforms, most learning management system like Moodle, Canvas, and Blackboard that we are usually using at most university now have built-in analytics dashboard. These dashboards show how often students log in, which materials they access, how much time they spend on lessons, and which quizzes they struggle with. So instead of guessing, teachers now can use these insights to understand engagement patterns and also to adjust their teaching accordingly. So now simply we can just open any subject, any group in any subject through Blackboard, and we can see the performance of the student, how much they spend in each, for example, in each activity, compare their grades on exam, which is like quizzes or midterms, or even compare their grades in the submitted assignment. Also, we have employing AI-powered recommendation tools that adapt content difficulty. Many modern educational platforms use AI now to personalize learning. For example, AI can recommend easier practice questions for students who are struggling or more advanced materials for students who are ready to move ahead. This adaptive approach also ensures every learner progresses at the right pace, something like that's almost impossible to do manually in large classes. Simply, we can just use Excel or Power BI or Python for programmers to visualize exam trends. Teachers don't need advanced AI to get started. Simply tools like Excel or Power BI or even Python can create visualization that highlight trends in exam result, which questions students struggled with, for example, or which topic needs reinforcement or how performance changes over time. These visual patterns can help teachers make data-based decisions and can make those decisions quickly and confidently. All of these examples show that data-driven teaching isn't about replacing teachers with technology. It's about giving teachers clearer visibility into student learning so they can support their student more effectively and they can help them to move forward before it's too late for them. So in education, data science helps us understand how students learn so we can teach better, support earlier, and personalize learning for every student. Let's bring everything together by introducing a powerful idea, the educator data scientist. This concept describes a modern teacher who blends both traditional teaching expertise with data-driven decision-making. The traditional teacher relies on tuition. So traditionally, teachers relied heavily on intuition, and intuition is valuable. But when we combine intuition with data, our decisions become even stronger. A data-driven teacher uses evidence, patterns, and analytics to confirm or challenge their instincts, leading to more accurate understanding of students' needs. Previously, the teacher were evaluated after exams. They typically evaluated learning only after major exams or assignment. But today, technology allows educators to monitor student progress continuously through quizzes, LMS activity, or even classroom interactions. This real-time insight lets teachers intervene earlier and support students before problems grow. Also, traditionally, lessons were designed for the average student, but data allows us to see that no two students learn the same way. We know students are different. They have different performances. They have different abilities. So the educator data scientist uses performance trends, engagement data, or AI recommendations to tailor learning pathways, giving each student what they need at their own pace. Also, teachers once spent hours manually grading and recording performance. Before, maybe around 10-15 years ago, teachers relied on manual grading of the student exams or assignment. But today, digital tools can grade quizzes instantly, highlight learning gaps, and generate dashboards. This doesn't replace teacher. It frees the teacher to focus on higher level thinking, monitoring, and also designing meaningful learning experiences. So the educator data scientist is not a different profession. It's an evolution of the teaching role. It's the teacher who uses data wisely, teaches with flexibility, and continuously adapt to help every student succeed. So teaching and data science share the same goal, understanding patterns of learning to improve outcomes. The teacher of tomorrow is not replaced by AI. She is empowered by it. What is the data science in education exactly? How we can explain data science or what is data science in education? We can simply say that data science is the process of collecting, analyzing, and interpreting data to make better decisions. In education, data science helps us understand how students learn, so we can teach better, support earlier, and personalize learning for every student. We can simply say that data science equals to data plus analysis plus insights plus action. The data can be student scores, attendance, feedback. And when we collect this data, we can analyze them by looking for patterns. If there is a specific question that all students got it wrong, how attendance of students affect their final grades, and so on. After analysis, we go to the insight. What helps students learn best? By understanding those patterns, we can find a way that helps students to learn best and to improve their performance. Finally comes action, which is adjusting teaching strategies. So, based on the analyzed data, the teacher can adjust their teaching way and add more strategies to help the different students with their different abilities. Why education produce valuable data? One of the reasons data science fits so naturally into education is because schools and universities are incredibly data-rich environment. We have massive amount of data comes from schools and environment every day. Every learning activity leaves behind a data footprint. For example, every quiz, attendance sheet, or assignment produces data. Think about it. Every quiz score or attendance record, every homework submission is a piece of data. When we combine these pieces, they create a detailed picture of how learning is happening across a classroom or even an entire institution. We have also online learning platforms that track clicks, time spent, and performance. Modern learning platforms like Blackboard that most of us are using now, Canvas that most schools are using it to give students some exercise through it. We have Moodle and Coursera that collect engagement data automatically. They track how long students spend on a lesson, which materials they open, how many attempts they need on a quiz, and all of this data helps us understand their learning habits. So simply you can go to Blackboard, click on any of the groups you have, and you can show the student patterns, how long they spend like on each assignment or each activity you give. Beyond numbers, we also gather qualitative data through surveys, comments, reflection journals, and course evaluations. These texts can reveal emotions, frustrations, and also suggestions that numbers alone cannot show. And today's AI tools can analyze this text to extract meaningful themes from them. We also have AI systems that collect continuous behavior metrics. New AI-powered systems can monitor learning continuously. They can detect patterns such as when a student, for example, is struggling or bored or progressing quickly. This kind of real-time data makes truly personalized learning possible. And here's the key point. If you have ever checked who submitted homework late or which quiz question most students got wrong, you have already performed data analysis. You are already using data to understand learners and improve your teaching. This is why education is one of the most powerful fields for applying data science, because the data is already there, waiting to be used, waiting to be collected, analyzed, and use this to improve the teaching way. Let's look at some practical ways data science directly support teaching and learning. Each example in this table shows how a simple data source can lead to meaningful action in the classroom. If we can take the first use case, which is identifying a struggling student, we can gather data from student grades or their attendance. And based on that data, we can take action like early intervention and tutoring. So when we combine grades and attendance, patterns emerge quickly. So students who miss classes, for example, or score low on early assessment are more likely to struggle later. Teachers can offer support, tutoring, or even check in before the problems grows. This is one of the most powerful uses of educational data. Another use case is improving lesson quality. We can gather data from student feedback, like give a survey or something to students and collect back. And based on their feedback, we can take action like adjust teaching methods. Feedback surveys, whether formal or informal, provide rich information. So if many students report that a topic was unclear or a teaching method like feels too fast or specific topic are difficult to be understood, teachers can adjust explanations, spacing, or materials to improve clarity and engagement. Feedback is a form of qualitative data that can directly guide instructional improvement. Another use case is personalizing learning. And we can gather data from student quiz scores or LMS logs and take action like recommend next level materials. Learning platforms track exactly which concept each student has mastered and which ones need review. This allows teachers or AI systems to personalize learning paths, so strong students receive advanced materials while other students receive targeted practice. It ensures that every learner gets the right level of challenge. The last use case, which is predicting success, we can gather data from historical data and take action like target support and mentorship. By looking at data from previous semesters, for example, such as past grades, attendance trends, or performance in prerequisite courses, we can predict which student may need support in the future. This is predictive analytics using past evidence to guide future decisions. It can help teachers plan mentorship or guidance or targeted intervention. These examples show a simple but powerful idea. Data becomes valuable when it leads to action. Even basic dataset like attendance or, for example, quiz result can generate insight that can help teacher personalize learning and also improve student success. On the following cycle, we can see the journey from raw classroom data to meaningful educational improvement. This cycle is a framework that any teacher can follow, which is simple, repeatable, and also consider a powerful tool to be used. The teacher starts in step 1 by collect, which is data collection. So, for example, in school and universities, this data comes from attendance logs or assignments submitted by student assessment, and even digital learning platforms like Blackboard. The goal is to capture meaningful evidence about how students learn. Then comes the next step, which is clean. Usually, raw data is often messy, incomplete grades, or maybe, for example, duplicate entries or inconsistent formatting. So before we analyze, we need to clean the data to ensure it's accurate and usable. Just we proofread a paper, we proofread our data for quality. Then comes the third step, which is analyze, where we uncover stories in the data. We look for patterns and relationships like, for example, how study hours or attendance affect performance. Even simple descriptive statistic or correlation can reveal powerful insight. Then comes step 4, which is visualize. Visualization makes data understandable. For example, charts, graphs, and dashboards can also help us see trends at a glance. A teacher could instantly notice which student need extra support, or even which topic require reteaching or change the teaching way. Finally, the most important step is the action. Data alone doesn't change outcomes. If we just collect data and watch trends or patterns, is not enough. This is where teachers personalize lessons, adjust methods, or introduce targeted support, turning data into improvement. The beauty of this cycle is that it's ongoing. Once we act, we collect new data to evaluate those actions, creating a culture of continuous improvement. So in this way, teachers truly become data scientists, experimenting, reflecting, and also refining their teaching based on evidence. A teacher is like a data scientist in the classroom, collecting daily evidence about learning, analyzing what works, and also constantly refining the approach. Now let's look at some practical tools that educators can use to begin working with data. The good news is you don't need any advanced programming skills to get started. There is a tool for every comfort level. For example, we can start by simply by Excel or Google Sheet, which are basic data cleaning and charting. These are the most accessible tools for teachers. With Sheets or Excel, you can clean data, remove duplicate. Also, you can filter student scores, calculate their average, and create a quick chart. Even a simple bar graph of quiz result can reveal insight about which topic student struggled with. Then comes like more advanced tools. So if you want to go a step further, you can use tools like Power BI or Tableau allow you to build interactive dashboards. These tools are great for tracking student progress over time or like comparing performance across classes. They turn raw numbers into visual stories that anyone can understand and use this data to improve. For those who want to explore deeper, Python offers powerful libraries such as pandas or data manipulation and matplotlib for visualization. This is what many universities and research teams use for learning analytics. Even simple Python script can uncover patterns that spreadsheets might miss. And today we'll go, inshallah, through one example using Excel and comparing it with Python in the upcoming slide. We also have platforms like Moodle, Canvas, and Blackboard, which consider as learning management system platforms. They already have analytics dashboard built in. They track login frequency, time spent on materials, quiz attempts, and assignment submission. Teachers can use this insight immediately without installing anything. So now you can go through Blackboard and see like your student, how many attempts they try to submit the assignment. You can compare their grades and see like which question that most students got like, for example, low grade on a specific question. We can also use Google Colab, which is a free cloud-based coding notebook. Colab is a great way to practice Python without needing to install software. It runs entirely in the cloud, supports datasets, and is perfect for beginners who want to try real data science tools. This is what many educators and data scientists use for quick experiments and classroom demos. Whether you prefer spreadsheets, dashboard, or code, there is a tool that fits your style. The goal is not to master all of them. One tool is enough, but choose the tool that helps you make sense of your data and improve your learning. You don't need to be a programmer to start. Even Excel is a great data science tool if you use it thoughtfully. So data science in education is not about replacing teachers. It's about empowering them to make smarter, evidence-based decisions that help every student succeed. Now that we understand data science looks like, how it looks like in education, let's explore how you can apply it through a simple hand-on activity, analyzing and visualizing real classroom data. We will now act as a data scientist exploring student data to find patterns. Our goal is to understand how study habits and attendance influence performance. We will work on student data, which is a CSV file that I already shared. I will share it again now. It's a link, a Google Drive link. If anyone wants to practice, you can use this file. I shared it on the comment. The file contains 60 student data, which is having study hours, attendance, their previous grade, and their final grade. We will explore this data using two tools, which is Excel and Google Colab. You don't need complex models to find valuable insight. Data analysis starts with curiosity, not coding. So you can easily start using Excel. or if you want to go through a simple coding, you can use Google Colab. So now let's go to Excel and Google Colab, and I hope now you can see my screen. Can you see my screen now? Okay. We will start by using Excel, and we will do the same using Google Colab. Here is the Excel file. We can simply just go to File, Open, and open our CSV file. So this file contains data for 60 students. We can start first by compare their final grades, or let's start by building a chart, comparative chart for those students. So we can go to Insert. We can choose any chart from here. If you prefer column chart or pie chart, here we can use scatter chart to see the student performance, which show study hours versus attendance versus their previous grade and final grade. We can see it clearly on the chart. We can also simply get their average. For example, we can write here average, and here we can say, we can only type average and choose average function, and we can simply select the student we want. If we want all student or specific student, we can select them easily, and then press click, and we'll get their average. So this is a simple way that we can compare student data using a simple tool like Excel. We can use more powerful tool like Google Colab. We can go to Google Colab from Google. Let me just change the account. We can go from Drive, then New, More, Google Collaboratory. Or we can go directly to Google Colab. Sorry, I think I have a connection problem. I'll try again. I already have the file, I think, somewhere here. There is a problem in Google Colab, sorry. We will open a new one. Okay, this is Google Colab. I will not go deeply on Google Colab, just I will implement with you what I already did on Excel to compare both. So here we can start by typing, for example, I already have those ready. If you want it, I can share it in the comment. So it won't take a long time. So just first upload the file and run it from here. After running, this part will appear. You can choose file and choose your CSV file. The file should be in CSV extension. So now the file is uploaded. We can go next or go to the next script here. We want now, we want Colab to read the file we already upload. So we can use import pandas at BD. This is pandas that pandas library that I already spoken about during the presentation. So one of the functions provided in this library is reading the CSV file. So now after uploading, we have to read the file. It copy the file with all of its content here. Then next we need to do same as we did on Excel. We need to find the average of their final grade, and also we need to create a comparison chart. So there is another code. We can simply type only this line here, which is df final grade dot mean, means give me the average or the mean of the student final grade, and simply we can run it. It gives the same number that we got on Excel. If we go to Excel again, here, it gives the same average that Excel gave. Then we want to create a comparison chart of the student attendance versus their final grade. So we can simply use those lines, creating a new code part. So we can import matplotlib. This is another library that I mentioned during the presentation, which is a library that help us creating the different chart using Google Colab. So we can simply run this and get the same chart, which is compare student final grade. Compare student hours, how many hours they spent versus their final grade. And we can say that the more they spent studying, the more they got on their final grade. These are the two simple tools that we can use to analyze the different student data, and based on this analysis we can see like the different levels of the student, and also their performances, and based on that we can improve our teaching style, or give more time to explain a specific part or specific questions for the student. Let's go back to our presentation. Now that we have experienced how to uncover insight from data, let's now look at how to interpret these results effectively and use them to improve education in real life. Excel gave us a visual idea that study hours and grades are related. But with one line of Python, we can calculate the actual correlation value, for example, a precise numerical measure of how strong that relationship is. This is where tools like Colab help teachers move from guessing to evidence-based insights. Excel is great for quick, familiar analysis, averages, charts, sorting. It's perfect for everyday classroom use. But Google Colab is perfect when you want deeper insight, automation, scalability, and statistics. You can repeat your analysis every semester with just one click. The most important thing is that both tools start with the same simply CSV, meaning every educator can choose the tool that fits their comfort level and goals. Which tool you think you feel more comfortable trying first, Excel or Colab? It's your way to choose what tools suit you, what you prefer to start with. So based on what we have seen on these examples, we can, for example, compare or see that low study hours result to low grade. In this case, we can introduce guided study session. We can see also poor attendance resulted to low scores, so we can create attendance alerts. We also see that high effort but low performance offer personalized tutoring and consistent improvement we can use as model for peer learning, for example, to improve student performance. We have many real-world examples. For example, schools now using dashboards to flag at-risk student early. They are depending on many platforms to compare student performance and give each student what they need. Also, universities using analytics to redesign difficult courses. Teachers adjusting homework policies based on performance trends. So these are real-world examples that show how teachers and data science are result to the same meaning. So data without action is just numbers. The real value is when teachers act on it. Data becomes meaningful only when it drives better learning. So the teacher can collect data and watch the different patterns, but if he doesn't take specific action, so there is no meaning of those data. Teachers don't just collect numbers; they turn them into actions that shape futures. We have learned how to analyze and interpret student data. In our next part, we will explore how teachers can develop the essential data science skills to do this confidently and professionally. Teachers have always analyzed data, test scores, feedback, classroom behavior, just without calling it data science. Today, with digital tools and AI, educators can make a bigger impact than ever before. The line between teaching and data science is disappearing. Now we have too many digital tools that help us to change the way we're teaching, to improve our teaching styles, and improve also the performance of our students. To make this more concrete, let me share a few real stories of how educators are already using data science to improve learning. These examples show that you don't need to be a programmer to make a meaningful impact, just curious and willing to explore. The first example is at one school, a teacher built a simple Excel dashboard to monitor student performance week by week. She tracked quiz scores, attendance, and assignment completion, and the dashboard automatically highlighted students who were falling behind. This allowed her to intervene early, not at the end of the semester, and she saw a significant improvement in class outcomes. What's powerful is that she did all of this using basic spreadsheet skills that most teachers already have. Another example is in a university setting, a professor took things a step further. He used historical data like attendance rate, GPA, login activity, like also assignment patterns, to build a simple machine learning model that could predict which students were at risk of dropping out. The model wasn't that perfect, but it flagged students who needed support early in the semester. This allowed advisors to reach out, provide help, and in many cases, keep students enrolled. This is an example of how predictive analytics can support real human connection and academic success. The final example is in some schools that now are using AI platforms that adapt learning materials automatically based on each student performance. If a student is struggling with a concept, the system provides easier exercises or additional explanations. If a student is excelling, it offers, for example, more challenging tasks. This kind of personalized learning used to be impossible in a large classroom before. But now, with all of the current AI tools, this makes it scalable and accessible for every learner. Teachers still guide the process, but AI helps ensure no student is left behind. This example shows that educators do not need to shift careers to become data scientists. They simply need to add data-informed tools to the work they already do, observing, supporting, and inspiring students. So a simple tool like Excel can help. Now that we have seen the value of data in education, let's talk about the key skills that help teachers grow into data-driven educators, or even full data scientists. The idea here is not to master everything at once, no, but to understand the core areas that will strengthen your ability to make evidence-based decisions. The first skill is data literacy, which is understanding dataset, variables, and relationships. Data literacy is the foundation. It means knowing how to read a dataset, understand what each column represents, identify patterns, and spot things that don't look right. Teachers are already familiar with interpreting grades and the progress report, so this skill comes naturally. You're simply expanding that intuition to a larger dataset. The other skill is statistic, means, correlations, and simple probability. Basic statistics help you interpret data accurately. Things like average, correlations, or, for example, simple probability are enough to start making meaningful insight. For example, do study hours correlate with performance, as we saw in the previous example? Or how consistent is a student's learning over time? You don't need advanced math, just essentials. Another skill is programming, which is basic Python for data analysis. Programming is optional at the beginning, but very helpful as you progress. So Python is the most common language for data science, and libraries like we mentioned before, Pandas, Matplotlib, makes it easy to manipulate data and create visualization. We also have skills like visualization, which is communication insight clearly. Data becomes valuable when it is communicated well. Tools like Power BI, Tableau, or Python visualization libraries turn complex information into clear, understandable charts and dashboards. Finally, we have machine learning, which is predictive modeling for deeper insight. Machine learning is the more advanced step. Once you are comfortable with data and basic analysis, you can begin using simple models to make predictions like identifying at-risk students or even forecasting performance trends. Together, these skills empower educators to use data with confidence, not to replace their teaching expertise, but to amplify it. And the good news is that you can learn them gradually, step by step, starting from wherever you are today. We only have maybe around 7 minutes, so we'll go faster from this slide. So we have explored skills needed to become a data-driven educator. Let's go on a quick and see how you can actually start learning them. And the good news is you don't need expensive courses or complicated tools. There are many free accessible platforms that allow you to learn at your own pace. We already mentioned some of them, like Google Colab, that we just use it to evaluate student data. We have also Kaggle, which is education dataset and tutorials. It's considered one of the richest platforms for learning data science. It has thousands of datasets, including many related to education, student performance, online learning behavior, exam result, and more. It also offers beginner-friendly notebook and short tutorials that can walk you through real analysis step by step. We have Coursera that most of us know, and also edX, which are structured courses. So if you prefer structured learning, Coursera and edX offer excellent introductory courses such as data science for everyone or AI in education. We have also WIDS Datathon, which is Women in Engineering, in Data Science Datathon, which is a global learning and mentorship. The Women in Data Science Datathon is a wonderful opportunity to join a global community of women learning data science together. It's not just a competition, it is a supportive environment where beginners can learn, collaborate, and receive mentorship. Finally, we have two tools that most of us are using, which is YouTube and GitHub, which are considered project-based learning. For those who enjoy practical, example-based learning, YouTube tutorials and GitHub projects are incredibly helpful. No matter where you are starting from, there is a pathway that fits your learning style, whether it is structured courses, hand-on tutorials, or even community challenge. What matters most is taking the first step and staying curious. Teachers do not need to become programmer overnight. What matters is adapting a data-driven mindset, using evidence, not just intuition. Today, we saw that data science isn't about coding. It's about curiosity, creativity, and improving how we teach and learn. Teachers have always worked with data. We always work with grades, patterns, progress, but now we can use technology to amplify that intuition with evidence. Women in data science are not just joining a trend. They are shaping the future of education, technology, and leadership. This is the end of my presentation. I hope you enjoyed everything, and if you have any question, you can ask, please. Is there any question? Thank you so much for your attendance, and hopefully we can meet again in the future in more workshops like this. Thank you so much, and see you again, inshallah.